Hello to everyone. François speaking from Dentaurum, Germany. The idea today is to present you in a short video all important aspects to use the laser welder. We have here the SL10 device. You can see the machine. We will see the different important aspects of the machine, and for sure I will explain you how to manage the energy. That's one aspect today, and I will also explain you some important aspects concerning the safety of the machine and some handling tips regarding the use of the machine. First of all, some hints regarding ergonomical aspects. The SL10 laser welder is a desktop device, so the machine has to be placed on a table. We are offering here at Dentaurum an electrical table. You can, it's very comfortable. As you can see, you can adjust the height depending of your need. It's very important to work without stress when you are looking through the microscope. You can also put the machine in a very high position to work, not by sitting but by standing. The second aspect is the seat. It's important to have place. If you put the laser on a bench, on a lab bench, that's possible. The distance here is appropriated to put the machine on a lab desk. So the important thing is to be able to sit in the proper way here and to adjust here the seat to work without stress when you are looking through the microscope. The last thing is the microscope, and that's not new things for a dental technician. He's used to work with the microscope. So basically you have to move the right ocular to see the surface clean. You have also to adjust the distance here to see one image. If the distance is not correct, you will see some black area that's not correct. So now some important safety aspects. First of all, you have here a curtain. This curtain should not be damaged. It's very important because the laser beam can come out of the laser chamber and damage, for example, the eyes of someone which is sitting close to the machine. So that's very important for the safety. Please keep it in order to close perfectly the working chamber. The second aspect is you can use these hand cushions and put the cushions in the machine, and so you will be able to work in the machine, to put your hand and to handle your objects in the machine like that. Without cushions, you are not able to have some safe position, and that's not so comfortable. So please, it's very helpful to use them, to put them here and to manage here to hand or to hold your objects like that. The last safety aspect concerns the argon bottle. When you are using a laser welder, we recommend to increase the quality of welding the use of an argon bottle. Yes, and so this argon bottle have to be fixed safely to the wall to avoid any problem, because if the argon bottle falls down, that can be a safety issue and a risk. So fix the bottle to the wall, and that's it. Argon is not a dangerous gas, so no problem with that, but fix the bottle piece to the wall. Let's now talk about the different ways to optimize the reliability of your laser welder. First of all, for sure, you need a certain knowledge concerning the materials. Secondly, we will see together the working step and the possibilities of adjustment of this energy. Let's speak now about the different working steps for an efficient working with the laser device. So first of all, you have to start the machine. And by starting the machine, you will see on the display different indications. And basically, you will be able here to adjust the energy. We will see that during the next step. As we said it at the beginning, you have also to work and to weld with argon gas. So you have to open the argon bottle. First, to open also here. And then to adjust the quantity of argon gas. We say between 6 and 8 liters per minute. It's basically more than enough. So we have adjusted the quantity of argon here with the external argon gauge on the bottle. Now we have to adjust the argon nozzle in the working chamber. And so when you have a look in the working chamber, you can see here this argon nozzle. Yes, and so you have to adjust the argon nozzle more or less at 1 centimeter from the spot. Yes, and when you have a look through the microscope, when you see the surface on your object clear, it's the right distance. And you have adjusted your distance in the working chamber concerning the argon nozzle and the spot. You can prepare your part and move your objects from the bottom of the laser chamber to the microscope. And so you will be able to check the quality of your argon coverage. You see the yellow spots are not bad but not optimized. The blue ones are very bad. You can imagine the oxidation. And you are also able to see these ones here without any kind of oxidation. That's exactly the goal you have to get. This is perfect here. You see the laser seam without any kind of oxidation compared to the yellow one or compared to the blue ones. So now some important hints concerning the working steps by welding. You can place your part directly on the plaster model or on resin model. That's not a problem. And you are putting your objects in the working chamber. And when you see the surface perfectly precise, as like that, that's not precise, that's perfectly clear. So now you are sure that you are on your proper level, you are placing your parts in the working chamber on the appropriate height. So you can work with the green cross on the display, but I think it's better to work by looking through the microscope and place your shots exactly where you need to place them. If you have a gap, that depends a little bit of how big is your gap, but we recommend when you have a gap to work always with filler material. Yes. This filler material can be a cobalt chrome welding wire, and you have different thicknesses. 0.35 is one option, is quite standard diameter that works more or less always. We are also offering 0.25 or 0.5 in cobalt chrome welding wires. So it's up to you, depending on the space, to choose a thinner one or a thicker one. And then you are looking, you are searching your area, and when you see the surface clear, you can make your shots as like that. First fixing, then welding, and the last step could be to get a very smooth surface. We will not do that here. I will show you that on some different pictures. You have different options to prepare the welding area. First of all, you should get, as possible, a good contact between the part, or close contact. If it's not possible, you work with a filler material, as we have shown it before. Another option would be to prepare the area with a disc, for example, to get something like that. And here you will place your retention, for example, here directly in this area, and so that will be very easy to fix it safely without too much energy, and it's stronger than putting the retention directly here. Now to the welding strategy. What means welding strategy? You have different options. For sure, you can join immediately and that's it. But in general, you have first to fix your parts and to choose for this step the adequate parameters. And they are low to fix. Then you will join the parts on your model. For that, you have to increase the energy. And at the end, if requested, you can make the surface of your laser beam smooth to get a very large spot and without deepness. So, to the welding strategy, first the definition of the parameters for fixing. You see here on your display, you have different options, basically 4 options. You can adjust the voltage, you can adjust the time, you can adjust the focus, and you can adjust here the frequency. That means the amount of shots per second. So when you increase the voltage, you have more energy basically. So you will get more deepness. Here, when you increase the time, you will also get more energy. When you increase the focus, you will get less deepness. And here, that the frequency 1 Hertz per second or 2 Hertz or 3 Hertz, that would mean 3 shots per second. Normally the standard is 1 shot per second, step by step. So first here we want to fix, so we have to reduce a little bit here, for example 230 volts. Here I will define, depending of the distance between my parts, I will define here the diameter of my spot, more or less. So 3 milliseconds gives me a small diameter. Here the focus, the standard for working is 0.8. You can also modify the parameter by increasing or decreasing your parameter here. And 1 shot per second, we have seen that I can also work with 2 Hertz, but I need, or I would like, to work very precisely. So 1 Hertz per second is 1 shot per second. That's more than enough. So that's it for my parameter for fixing. You have now in your working chamber your part on the model, or you can also work freehand. And you remember that you need a good contact between the parts. So here I have a very precise contact. So I made 2 shots, and now the parts are fixed. And you see the shots are not showing any yellow or blue aspect, so the argon covering is optimized. So with this parameter, I will be able to move my part to check the fit of my parts on the model. So it's easy also to move a little bit to adjust on the model the parts. The second step is to join the part. And for joining the parts, I have now to increase the time and also the voltage. So first of all, I show you here, it's easier to see. The voltage and the time, both parameters will have an influence of deepness. So I increase first the voltage. I can also increase the voltage like that. Not too much. So, and I will also increase the time a little bit. To get a spot which is a little bit larger. Okay, these both parameters are correct. That depends for sure of the thickness of your parts. Yes. So, and you will see now on my object the difference compared to my first shots. You will see the difference. You see my first shots here with low energy. And now I can show you the difference with these shots. So, definitely you can see the difference between both. And if you are looking at the back, you will also see the difference in deepness. Yes, the first shots, you can see them on the other side. And the last one, you can see that you are reaching a high deepness. The goal is to get more or less the middle of the total thickness of your part. That's enough. And now you could place that's it. So you remember the first step from the welding strategy was fixing with low energy. The second step was joining with higher energy. And now the last step is to create a very smooth surface. That's not always necessary, it's more an optical aspect. But I will get this effect of smoothing by increasing my diameter here. You remember we were first for joining by 0.8. Now I have increased it more or less to the maximum, that would be 2.0. And now, after choosing the parameter, you will see the difference on my surface. As you remember here, look at the cross. That was fixing. The second step was joining, and the last step, smoothing. You see the difference? You have these 3 options. So smoothing is the last step after joining. So we have our parts here, you remember after joining. This parameter were the parameter for joining both parts. And now you can see the difference. If I go on the joining parameters, you see the difference? That's it. Concerning the adjustment possibilities to modify the parameter, you can do that from outside on the display. You can move here, you can change the voltage, you can also change the time or the focus increase or decrease, or the frequency increase or decrease. Yeah? Another option is to switch to the working chamber. And in the working chamber, you can also, with the joystick, change the parameters. Yes? So I will show you that. So you will see it more clearly with the Pro mode. So now in the working chamber, you remember that you can adjust here manually on the display all parameters, or you can do the same here with the joystick. It's very ergonomical and easy. So first I have to define which parameter have to be changed. And so by moving the joystick from the left to the right, I will change. You see here, for example, the parameter Hertz frequency is active. Now I move to the left, and you see another parameter, the time is active. Yes? So here the Hertz, here the time, the focus, here the voltage. And now in the working chamber, on the display, I see the diameter is active at the moment. Yes, you see here the diameter is active. So if I want to change that, I can do that with the joystick, increasing with the joystick or decreasing with the joystick. So if I prefer to change the time in milliseconds, I can move the joystick from the right to the left in the working chamber, and now my time, my milliseconds are active, and I can increase or decrease the time. And the same for the voltage or any other parameter. So if I push my joystick horizontally from the right to the left, now I have the voltage active, and now I can increase the voltage. And you see the voltage, the increase of voltage is very, very fast. So you will always have in an extremely short time the energy requested for your weldings. From the point of view of the ergonomic aspect, it's very easy and comfortable to change the parameter in the working chamber. So with the different parameters, voltage, time, diameter, you will be able to define a certain amount of energy. This energy can be managed in deepness and in diameter. And so you can see here on the display, for example, on the left you have a little bit less energy, and then moving to the right I have more energy, and more energy means more deepness. More energy can also mean too much energy. You see the last shot, you have a hole in the part, so that's not ideal. So, and here we are not speaking about the management of the deepness, but about the management of the diameter on the surface. And you see on the left side, the first shot is a very small one. And the next ones going from the left to the right are larger. You see that they become larger and larger and larger. You can also manage the diameter on the surface in a very easy way by moving or changing here the diameter. If you decrease it, you will get a smaller spot, and if you increase it, you will get a larger spot. But less deepness. So with the laser welder, you can weld different kind of parts independently if you are in front of some prosthetic parts or if you are in front of some orthodontic parts. Basically, the important thing is to consider the thickness and the type of the parts. So for example, first, as an example, you have some big parts, two big parts. For sure, you can join these very thick parts without any kind of problem. But you can also join thick to thin parts. Here another example. So you have here firstly joined the thick to the thick part, and here you have joined a thin wire to a thick bar, for example. And that's perfectly possible. You have an extreme difference of size of both materials, but it's absolutely not a problem. You will define your energy considering the thinner parts to get a nice and oxide-free laser seam. With some wires, mainly in orthodontics, you can join different type of wires, very thin ones, thicker ones, thin to thick ones. You can do that very easily. Here, for example, you have joined the wires, and it's up to you to choose a large laser seam or a small laser seam. You see on the left a large one, and on the right a very small one. The resistance of both is enough, is strong enough. It's up to you. It's not optical aspect. It's up to you to define what you want, and then to define the welding parameters to do it. In the field of orthodontics, sometimes you have to weld the wire with a band. And so in this case, you need a very good close contact from the wire to the band, and then you can place your shots like that. As you can define your seam, a small one, a largest one, and take care, avoid some perforation. You will always see a certain oxidation, I would say, but that's absolutely not an issue. The main thing is to avoid any hole due to too much energy. Here another example in the field of orthodontics. We have joined the wire with the band and also with another wire here. And at the end we have here the contact with the palatal screw. So that's also very interesting. With the laser welder directly on the model, you will avoid any kind of soldering material. You will avoid all is negative aspect of corrosion. You have here a very mechanical stable joining, a nice aspect. and a high precision directly on the master model, and you will be able to control each shot. And that's only possible, I would say, if you are able to adjust very precisely your energy. We have a prefabricated tube, and we have with the laser welder to join the tube with the wire. And so it's quite difficult to see the laser seam. The laser seam will be here. For sure, it's very important in this case to be able to adjust very precisely the energy to avoid any damage in the inside the tube, to be sure that we will get a safe function of the tube and of the wire in the tube. So that's a very interesting aspect, and that's only possible with a laser which can be adjusted very precisely. Concerning a cobalt-based framework, we have repaired very closely to the resin the clasp, and you can see here that we have first fixed the clasp, then we have joined the clasp with help of a cobalt-based wire, and then we made a very smooth surface. On the same framework, we also made on the bar a modification by fixing a retention. Yes, and so you can also see here the working step. In this case, we worked also with additional filler material, and we fixed, joined with filler material, and made a smooth surface by finishing. Here another example. We have to join different prefabricated titanium bars to obtain at the end a prefabricated titanium bridge. So you can see here we have joined with the laser welder the several prefabricated parts. You see a very nice and oxide-free laser seam. Titanium cannot be soldered, so you need a laser welder for that, and you have to work with argon gas. That's absolutely necessary to avoid by joining any kind of oxidation. For this kind of cases, the preparation before welding is very important, a close contact, and then the welding strategy with fixing, joining, smoothing, and at the end, perfect control of the fit. So, as a very precise additional information, you will find in the instruction manual a lot of hints and informations. Please have a look, especially in the chapter 3 and in chapter 6. You will find all these information concerning, in chapter 6, the maintenance of the machine, and in chapter 3, the product descriptions with the different functions of the machine. So that's an important document which is available for you. You can also find in our product catalog prosthetics in the part equipment, different accessories, laser welding wires, and also some information concerning some optional parts you could need to use in a comfortable way the laser welder. So don't forget the product catalog.